So, like we said before, you're going to be finding the mass of an element in a compound. We do that by finding the atomic mass of it. We can find individual ones by using our periodic table. And on the periodic table, we're going to be using the number that we have already talked about before, and that is the mass number or the atomic weight. Remember, this up here, 86 represents the number of protons, and if you add up all of these numbers on the side right here, this is the total number of electrons. So this total of all these numbers should equal 86 if you add them all up. And so this is radon, and it has an atomic mass of 222. Most of ours, we're not going to use that large of a mass. So, that being said, we are going to find the sum of the entire compound. This compound happens to be 66H12O6, and we're going to find the sum of each one of these elements in here. The way that we do this, though, is we have to figure out and remember that there are 6 carbons, 12 hydrogens, and 6 oxygens. So we're going to multiply the mass, which would be X, or we're going to have to multiply the mass by the number of atoms. So carbon is 12.011, hydrogen 1.008, and oxygen is 15.999. Now you'll see some places that will actually round this up, and they'll just put down 16 for oxygen. Just kind of depends on the periodic table that you're looking at and what year it was published. You'll notice that over here we're going to put those numbers in, like hydrogen, carbon, I'm sorry, I went the wrong direction. We already had these, so carbon is here, hydrogen is 1.008, and oxygen is 15.999. Notice that our limiting factor is going to be hydrogen because it only has 1, 2, 3, 4 sig figs. Sig figs are important whenever we're working a problem in molar mass because they're such a small number and not always easily obtained. So, we look at this one first. We see carbon. There are 6 of them, so we're going to multiply times 6 and get 72.066. The next thing we'll do is we're going to multiply the hydrogen, which is 1.008 times 12, and we're going to end up with 12.096. That allows us to see the full mass of hydrogen in that molecule of sugar. And then oxygen is going to be multiplied times 6. So the hydrogen is multiplied by 12, the oxygen is multiplied by 6. We end up with these numbers here of 72.066, 12.096, and 95.994. When we get done getting these totals, we have 180.156. That's how much it is, the sum of all of them. So we're going to find the sum of all 3 of these here. Now, if it makes you feel better, you can put a plus sign and a line underneath it and put the total underneath it. Some people can do it this way. Other people, they feel better about putting it down below and just using it like a regular math problem where you put a plus and a line and summate all of this together. Moving down now, let's go down to number 4. Number 4, we're going to plug in the values from step 3, and we're going to use 4 sig figs down here to do this. So now, now that we've found this, we can now work off of our percentage. So this was the first part, understanding and finding the molar mass. This is what we would call the molar mass, or the molar formula mass sometimes. Or I guess they call it formula molar mass. FMU. So, you're going to have 3 steps to this. we're going to have the mass percent of carbon will be our first one. Then we're going to have a mass percent of hydrogen and a mass percent of oxygen. Because just looking at it, we cannot figure out how close it would be. We could probably ballpark it and get a rough estimate by looking at it. And if you knew like the masses of things, you could say, well, I know that oxygen is heavier than carbon because it has a larger atomic number. And so that would allow you to rationalize and say, well, oxygen has to be the highest and then carbon because I know hydrogen is the least. So if we would rank them in order, we would say from lowest to highest, we would say hydrogen, carbon, and then oxygen. And so let's see what percentages we get if that's true. So carbon, you're going to put 72.066 AMUs. And we're going to divide that by 180.156 AMUs. Because this is the part and this is the whole. Remember our basket of fruit analogy I was talking about that you would carry up from like elementary? You have a basket of fruit that has a mass of 180.156. And then the, cherries are 72.066 is that part of the mass. So what you do is you take this one and you divide it by that. You take the top divided by the bottom. And when you divide the top by the bottom, you're going to then multiply the answer times 100. And that's going to give us 40.00%. Now, why did I carry that out to 4 or 3 zeros, like 40.00? Why did I do that? That is my sig figs. That is correct. If my sig figs are being analyzed correctly, I would have gone back up and looked at my original numbers, found that hydrogen gave me my 4 sig figs with 1, 2, 3, 4, and that's why I use my 4 down here. Because my number comes out to be larger than that. We then do the second one, which is hydrogen. Hydrogen is 12.096, and we divide that by the same number of mass for the entire amount of the element, or of the compound of sugar. And so when we divide that out, we get 6.714. Sorry about the 7. It kind of got messed up from the sheet underneath when I was writing it. That is true. The 6-7 does not have to be perfect. So we then go to oxygen, and we have the 95.994 divided by the same number on the bottom of 180.156, giving us a total of 53.28%. Each one of these are 4 sig figs, which allows us to figure out our percentages. So I've slid the paper up a little bit, and this kind of harkens back to what we did earlier. This is what was on our past test. I wanted to kind of show you some more about it to kind of re-emphasize what we're looking at. So the moles of a compound, however many moles you have in a compound, we can use this atomic mass units up here of that 180.156 to actually figure out what the mass in a sample of grams would be. And so we know that a mole of a compound, and then we also know it's equal to the mass of a sample in grams divided by the molar mass of a compound, which is a grams per mole. Now, where do we find the molar mass? We're going to find the molar mass from coming back into our in here on our actual chart. Because remember that, like on strontium, 87.62, that represents 1 mole of strontium. And 87.62 grams of strontium is 1 mole also of strontium. A mole is equal to its molar mass, just like a gram is equal to its molar mass. Now, that's not talking about molecules, that's just talking about molar mass. So, this top part represents the x grams. X grams is the top part. And what we have here is a fraction divided by a fraction. You see a gram divided by a gram per mole? That's actually a fraction divided by a fraction. Now, we didn't get to do a lot of conversions, but I always tell people anytime you have a gram divided by a gram per mole, like this, we got this type of a fraction divided by a fraction. What it actually is a gram over 1 divided by a gram over a mole, like this. That's actually what this represents. And so the way that we work this out is you're going to write down the grams over 1, and then you would multiply this one by the reciprocal of grams per mole. Remember when you had a fraction divided by a fraction, you invert and multiply, or you flip you take the reciprocal and multiply? I know most of you have forgotten that, but lo and behold, that comes back to haunt you if you're not careful. So these grams, would they cancel, and that leaves me with moles. So this is what it would look like. You would have x grams, and then this would be the y grams per mole down here, and it inverts, or it flips over. So we would flip this over, and then grams would cancel. You'd take x times 1 and divide it by y, and that gives me the answer of z moles. No, it's not French. Z mole. Let's assume we're going to say that we have 13 grams. This 13 grams represents the mass of the sample in grams. 13 grams. And then we know that 12.011 grams of, let's say, carbon that would be grams of carbon. So the molar mass would be 12 grams over 1 mole. So what we're going to do is we're going to flip it over. And the way that this would look, if you were actually working it out at the beginning, you would start out with like this. You would have 13 grams of carbon, and you would be you would be dividing this. You would be dividing it by 12.011 grams of carbon divided by 1 mole of carbon. Like that. And so when we write this out, we would put 13 grams of carbon down, and then we would multiply that times, and we would have to take the reciprocal of this. So when we take the reciprocal of it, this, we would have 1 mole on top, so 1 mole of carbon on top, and then we'd have 12.011 grams of carbon on bottom. Notice that the grams of carbons are going to cancel, and that leaves me 13 divided by 12.001, and that gives me 1 point, I think it is, if I remember right, it's 1.0, oh shoot, I forgot the number now. 13 divided by 12.011 equals 108.234187. Okay? And that's going to be moles. But we only have how many sig figs? There are only 2 sig figs. So we would come here. This would be 1, this would be 2, and then the 8 rounds that up, and that gives me 1.1 moles of carbon. So make sure that whenever you work your problems, come back to this sheet if you need help on it. We're going to have a worksheet tomorrow that will pertain to this and a few other things. So take the time, look over it. Once again, you're more than welcome to go look in the chapter. Go read chapter 6.2. Look in there. Maybe that helps you better. I don't know. It's all an individual idea. Some of you might find videos online that help you out, or a website, but you're going to have to do a little bit of outside investigation, because I don't know all the ways to teach it to you. So you'll have to make a decision on what works best for you, because not everybody learns the same way. So